Good morning, class.
Good morning, sir.
Good morning, sir.
What is the strength of this class? Total strength?
Sir, 22.
22. And I hear only two guys. So rest are not there. All of you are here, I guess. Okay. So tell me what we were discussing in the last class. I think we were done with normal distribution, right?
Sir, could you please start the normal distribution once again?
What should I do with normal distribution again?
I mean the concept of normal distribution. Could
The
you please
concept of
say
normal
it?
distribution.
Yeah.
Okay, I can do that. All right. So anyone else has any doubt on normal distribution? Did you guys try numericals? Did you guys read more about it? Anyone faced any difficulty? Tell me. If any one of you have any concern, you can raise it right now. Okay. So let me first repeat the basic concept behind normal distribution, and then we move to the next topic. So let me share my screen first. So as you know, this normal distribution deals with basically distribution of any quantitative variable in the population. So what I told you through this graph was, so if we are working on any say biological quantitative variable and we took the example of height, you can take the example of weight also, or any other variable which is quantitative in nature. So since we took the example of height, let us continue with this. So we had collected data from some samples and we measured their mean height and it was 170 centimeters, and standard deviation we measured came out to be, let us assume, 5 centimeters. So what this normal distribution does, it uh, basically converts your data in terms of mean and standard deviation, and then it can explain the distribution of all your samples with these mean and standard deviation. So what this normal distribution tells you is, when you see the distribution of these samples, they always show a bell-shaped curve. Okay, so if your data shows bell-shaped curve, and if it additionally shows some more properties, then it follows normal distribution. So what are those additional properties? So bell-shaped curve, it is unimodal.
Sir, your voice is
That
breaking.
means you have only one peak.
Sir, your voice is breaking.
Mean, median. Do one thing. Let me try to connect it with another network. Just wait for a moment. Now. So what I was telling you guys was, if we uh, see the distribution of our measurement, so we find a bell-shaped curve. Okay, and the other property for normal distribution is you only have one peak in your data. That means it is always unimodal. Okay, only one peak, only one mode, and all three measures of central tendency, mean, median, mode, are same. So for normally
Sir, your
hand
voice
side
is
of,
breaking.
my voice is breaking. What should I do? Okay, let me see if I can do something else also. Because I tried connecting with my mobile data also. Earlier I was using my Wi-Fi. Let me try to place my phone somewhere else. Is it better now?
Yes, sir.
Okay. So what I was telling, that the shape of this curve is symmetric around mean. That means 50% of the data points are on the left hand side of mean and 50% are on the right hand side. And the two shapes on the left and on the right, they are mirror images. Okay, they are exactly same. Then the next properties I told you guys is tail of the curve. So you see that you have two tails, one on the left hand side, one on the right hand side. Tail of the curve gets closer to x axis as you move away from the mean. So agar ye mera mean height is here 170 centimeter, number of individuals. So जैसे जैसे आप mean से दूर जाओगे, if you go on the right hand side, that means you are going towards taller people, and if you go on the left hand side, that means you are going towards the smaller people or shorter people. So their number will keep on decreasing. जो extreme heights हैं, बहुत short height के लोग हैं या बहुत tall height के लोग हैं, उनका number is, it will be then there is this very important properties of normal distribution, which is 68 95 99 rule. तो ये मैंने आपको explain किया था, 68 95 99 rule. So what I told you is plus minus 1 standard deviation around mean covers 68% of area under the curve, or percent data points. Okay, plus minus 2 standard deviation covers almost 99%, sorry, 9%. Okay, and plus minus 2 standard deviation away from mean, sorry, 3 plus minus covers almost 99% of the data points. तो ये हमने मेनली नॉर्मल डिस्ट्रीब्यूशन की प्रॉपर्टीज को डिस्कस किया था, एंड यूजिंग दीज प्रॉपर्टीज यू कैन स्टडी एनी बायोलॉजिकल वेरिएबल विच इज क्वांटिटेटिव इन नेचर. ठीक है, सो सपोज यू आर स्टडिंग से ब्लड शुगर लेवल इन द पॉपुलेशन. ओके, so you can take sir let us assume you have taken data from 200 individuals, 200 लोगों का आपने ब्लड शुगर लेवल चेक किया है. Okay, so you can calculate their mean, you can calculate their standard deviation. So suppose the mean blood sugar level for these 200 individuals is say 85, and the standard deviation is For example, say 15. Okay, so mean is 85, standard deviation is 15. और अगर किसी का value is more than 100, so that person is considered as diabetic. Okay, so through this normal distribution, now you can tell out of these 200 individuals, how many you think should be diabetic. So plus minus one standard deviation around mean covers 68%, right? So 85 plus 15 is 100. So 68% plus minus. So if this is 85, तो अगर मैं इसको हाइट ना लेके यहाँ पे मैं इसको ब्लड शुगर लेवल बोल देता हूँ. So this is 85 here, right? So plus 1 हो जाएगा 100 and ये minus 15 हो जाएगा आपका 70. So this range covers 68 ये वाला एरिया. ओके, 68 के बाहर कितना बच जाएगा आपका 32. So 32 का 16% will be on this side, 16% will be on this side. So now you can plan
Your voice is breaking. Your voice is breaking.
you have the access to our last session.
So your voice is breaking.
Yes, I also get this message again and again. Bad quality network. I don't know what to do because I tried my Wi-Fi, I tried my phone, and in both cases, you are complaining that it is bad quality. I can do one thing. All right. So let me play that video again. Okay. So probably you'll not face that issue. So let me play that video of normal distribution. That should clear some of your doubts. Okay.
$5.99.7 rule.
Okay, all of you watch this video again, and I think this normal distribution should be clear. Okay, and you all can do one thing. If you still have some doubts, you can go back to the last classes recording, go through it, and I'm sure it will be you will be able to understand everything. And if you still face any doubt, you can then report it to me. Okay, so I'm starting this video.
In this video, we'll be learning about the normal distribution and the 68.95.99.7 rule. When we talk about normal distributions, we refer to data we get from a population or sample. So before we actually talk about the normal distribution, we need to first distinguish the difference between a parameter and a statistic. A parameter is a number that describes the data from a population, whereas a statistic is a number that describes the data from a sample. Examples of parameters and statistics are the mean and standard deviation. But because of the definitions we just talked about, we have to be very careful with what symbols we use to represent these numbers. When we are dealing with a sample, we use the symbol x bar to represent the sample mean, and we use the letter s to represent the sample standard deviation. These are statistics. When we are dealing with a population, we use the Greek letter mu to represent the population mean, and we use the Greek letter sigma to represent the population standard deviation. These are parameters. The population parameters mu and sigma are very important when we talk about normally distributed populations. So what is a normal distribution anyways? A normal distribution is a special type of density curve that is bell-shaped. For this reason, the normal distribution is sometimes called the bell curve or the normal curve. The normal distribution describes the tendency for data to cluster around a central value. In fact, this central value is the population mean mu, which is always located in the middle of the curve. So for any normal distribution, we can say that some data points will fall below the mean, other data points will fall above the mean, but most of the data values are located near the mean. The normal distribution and its shape actually arises from many different variables found in nature, such as weight, height, volume, blood pressure, and many more. This is why the normal distribution is commonly studied. For example, exam scores are known to follow a normal distribution. Some people do great on exams, some people do poorly on exams, but a large majority of people score near the average or the mean. In this example, the average exam score is 50 because it is located in the middle of the curve. Now that you know what a normal distribution looks like, we need to talk about the population mean mu and the population standard deviation sigma. Both of these tell us important information about how the normal distribution looks. We'll talk about the population mean mu first. The population mean mu characterizes the position of the normal distribution. If you increase the mean, the curve will follow and move towards the right. And if you decrease the mean, the curve will still follow and move towards the left. This happens because the data will always cluster around the mean in normally distributed populations. As a result, the value of the mean determines the position of the normal distribution. On the other hand, the population standard deviation sigma characterizes the spread of the normal distribution. The larger the standard deviation, the more spread out the distribution will be, and the smaller the standard deviation, the less spread out it will be. Notice that when the spread increases, the curve gets much flatter, and when the spread decreases, the curve gets taller. The reason for this is because the normal distribution is a density curve, and the total area of any density curve must remain equal to 1 or 100%. So changes in the width of the curve must be compensated for by changes in the height of the curve, and vice versa. The normal distribution is unimodal. This means that the distribution has a single peak. The normal curve is symmetric about its mean, so you can clearly see that the distribution can be cut into two equal halves. The parameters mu and sigma completely characterize the normal distribution. The population mean mu determines the location of the distribution and where the data tends to cluster around. The population standard deviation sigma determines how spread out the distribution will be. The notation given to a population that follows a normal distribution can be written like this. Although it looks scary, it means what it says. For the variable x, it follows a normal distribution and has the mean mu with a standard deviation of sigma. Now that you've been introduced to the normal distribution, we can talk about the 68, 95, 99.7 rule. If we were measuring the heights of all students at a local university and found that it was normally distributed with a mean height of 5.5 feet and a standard deviation of half a foot or 0.5, we can construct a normal distribution as follows. From here, we can create intervals that increase by the standard deviation. So we'll have 6, 6.5, and 7, and on the other side we'll have 5, 4.5, and 4. So what the 68, 95, 99.7 rule says is that within one standard deviation away from the mean, it contains a total area of 0.68 or 68%. Because of this, we can say that 68% of the population are between 5 and 6 feet tall. And if you go two standard deviations away from the mean, it contains an area of 95%. This means that 95% of the people in the population have a height between 4.5 and 6.5 feet. And finally, within 3 standard deviations away from the mean, it contains a total area of 99.7%. This means that, for the population we are studying, 99.7% of the people are between 4 and 7 feet tall. Now you might be wondering, what happens if we go 4 standard deviations away from the mean, or 5 or 6 standard deviations away from the mean? And to answer that, you actually can. A normal distribution actually never touches the x-axis. It continues on to infinity. So you can go as many standard deviations away from the mean as you want, but the area contained within these regions will be very very small. 689599.7 rule is a great way for approximating the areas of a normal distribution, and this works for any normal distribution no matter what shape and size. So let's do some practice questions. Feel free to pause the video at any point so you can try these questions for yourself. Question number 1. The normal distribution below has a standard deviation of 10. Approximately what area is contained between 70 and 90? In this question, we know that the population mean is equal to 70 because it's in the center of the distribution. We also know from the question that one standard deviation is equal to 10, and we can see this because each interval goes up by 10. According to the 689599.7 rule, we know that there is an area of 95% contained within two standard deviations of the mean. Two standard deviations to the right gets us to 90, and two standard deviations to the left gets us to 50. According to the 689599.7 rule, this means that there's an area of 95% contained within this interval. However, we are only interested in the area from 70 to 90. So dividing this area by 2 gives us our area of interest. 95% divided by 2 gives us an area of 47.5%, and that is our answer. Question number 2. For the normal distribution below, approximately what area is contained between -2 and 1? In this example, we know that we have a mu of 0 because 0 is in the center of the distribution, and we know that we have a sigma of 1 because each interval goes up by 1. To approximate the area between -2 and 1, we will use the 689599.7 rule. We can strategically divide this area into two parts so that we can easily incorporate this rule. We'll start with the right half, which goes from 0 to 1. We know that one standard deviation away from the mean gives us 68%, and half of this is 34%, giving us our area from 0 to 1. The next half goes from 0 to -2, but we know that within two standard deviations from the mean, we have an area of 95%. Dividing this by 2 gives us the area from 0 to -2, which is equal to 47.5%. And finally, to get the total area contained between -2 and 1, all we have to do is add these two areas together. And when we do, we get a total area of 81.5%. If you found this video helpful, consider supporting us on Patreon to help us make more videos. You can also visit
All right, guys. I hope Yuvraj now it is clear to you. Yes, Yuvraj. You guys are able to hear me?
Yes, sir.
Okay.
Yes, sir.
All right. Very good. So today we are supposed to learn about next topic, which is binomial distribution. So in normal distribution, we were talking about quantitative data. What if we have qualitative data? So the distribution of qualitative data can be studied through binomial distribution. Binomial distribution. So what happens in binomial distribution? So this deals with the types of variables that have got only two outcomes. So you see by means two. The two outcomes. Outcome of your interest is called as success, and outcome that is not of your interest is called as failure. So suppose you want to know what are the chances that if I choose a person randomly from my class, that person is a male or a female. Okay. So if you are looking for like a male student, so if you get male student in your choice, then it is a success. If it is female, then it is a failure, right? So it can be success, failure, it can be true, false, yes, no, near, far, anything. You can have more than two categories also, but you have to see the distribution in terms of only two outcomes. So suppose you are working on say socio-economic status, so that then it can be high, it can be medium, it can be low. So you can study this also through binomial distribution, but then you have to make two categories. So if you are interested in like finding out the chances that someone from your class is of high economic status, then you have to club these two, high versus not high. Or if you have say cancer stages, so stage 1, 2, 3, 4, and you are looking for like patients with stage 2, then you have to club stage 1, 3 and 4 together, so 2 versus non 2. Okay, so that way you can club different categories and make them into 2 and then study it through binomial distribution. So whenever you are studying binomial distribution, your data should show certain properties, then only you can study it through binomial distribution. Okay, so what are those properties? So let me give you one example first, one question, and based on that question, then we'll try to understand the properties and we'll solve one question. So suppose you are tossing a coin 10 times. Okay, you are given a coin, it is a fair coin, and the coin has two sides, heads and tail. Okay, you are tossing that coin 10 times. So what do you think, in a normal coin, how many times you should get heads and how many times you should get tails?
What's up?
I am tossing a coin 10 times. So what do you think, out of these 10 tosses, how many times I should get heads and how many times tails? Okay, let me ask this question to Ishita. Ishita. Ishita, are you around?
Yes, sir.
So what is the answer?
Sir, can you repeat the question once again?
The question is, I am tossing a coin 10 times. How many times I should get heads and how many times tails?
I'm not sure, but it's 1 by 10, the possibility of heads and tails.
Okay. Shakti. Shakti, what do you think? Shakti is not in the class. Okay. Then Nandini. Nandini. Not in the class. All right. Sanjana.
Yes, sir.
So what should be the answer? What do you think?
Sir, 1 by 2.
No, tell me the counts. 1 by 2 is correct. I want
Sir,
the count.
sir, 5.
Yes. So अगर आप टॉस करते हो कॉइन को, 5 बार हेड्स आएगा, 5 बार टेल्स आएगा. If the coin is fair, मतलब that is the probability, right? इज नॉट ऑलवेज श्योर कि 5 बार हेड्स ही आएगा या 5 बार टेल्स ही आएगा, बट द चांसेस आर आउट ऑफ 10 टॉसेस 5 टाइम्स यू गेट टेल्स, 5 टाइम्स यू गेट हेड्स. ठीक है. सो व्हेन यू टॉस अ कॉइन वन टाइम, तो हेड्स आने का और टेल्स आने का कितना चांस रहता है? 50%. 50% चांस है कि हेड्स आएगा, 50% चांस है कि टेल्स आएगा. तो इफ अ न्यू बेबी इज बॉर्न, वो मेल होगा कि फीमेल होगा, क्या चांस है? 50%. 50% चांस है वो मेल हो सकता है, 50% चांस है कि वो फीमेल हो सकता है, राइट? इफ देयर इज ओनली वन आउटकम पॉसिबल, if there are two outcomes and you get only one outcome at a time. ठीक है. So in case of tossing a coin or in case of baby being male or a female is always 50%, right? So now the question is, I am tossing a coin 10 times. Okay. The probability of success is heads is a success. If I'm looking for tails, tails is a success. So that is always 0.5 or 50%, right? Now I want to know, if I toss a coin 10 times, what are the chances that 8 times I get heads? ठीक है. So मैंने बोला 5 times heads आएगा और 5 times tail आएगा, उसका chances 50%. 5 times heads आने का chances 50%, 5 times tails आने का chances 50%. तो 7 times या 8 times heads आने का क्या chance है? Since we have only 2 outcomes possible, so can we study it through binomial distribution? So for binomial distribution, your data should show certain properties. So basically there are 4 properties that it should show. What are those properties? Number 1, number of trials, or you can say experiments, should be fixed, and it is denoted by small n, right? So how many experiments you are doing, that should be fixed. So like I am tossing the coin 10 times. So each toss is one experiment. उसका कुछ भी outcome होगा ना. So first toss में you may get head, second toss में you may get tail. It can be anything, but the tosses or the experiments are fixed. It is 10 times. The next property is the probability of success is same in each trial. तो फर्स्ट टाइम आपने टॉस किया तो हेड आने का क्या प्रोबेबिलिटी है? 50%. सेकेंड टाइम किया 50%, थर्ड टाइम किया 50%. नाउ लेट अस अज्यूम यू हैव डन 6 टॉसेस और हर एक टॉस में आपको जो हेड है वो हर एक टॉस में हेड आया है आपका अभी तक. ठीक है. सो आउट ऑफ 6 टॉसेस यू गेट 6 हेड्स. सो 7 टॉस में हेड्स आने का चांस इंक्रीज हो जाएगा, ऐसा तो नहीं है ना? उसमें भी उसका चांस 50% ही रहेगा. So probability of success is same in each trial. Each trial is independent. So first trial में क्या आया है आपका, सक्सेस आया कि फेलियर आ रहा है, वो आपका नेक्स्ट ट्रायल को इन्फ्लुएंस नहीं करेगा. So the number of trials is fixed. Probability of success is same in each trial. Each trial is independent, and probability of number of trials are fixed. Each trial is independent. Probability of success is same in each trial. And there is one more property. I am forgetting it. Just let me check. Was that? Yeah. So there are only 2 possible outcomes. Okay. So the one more property is 2 possible outcomes. जब भी आप कोई ट्रायल करोगे, कोई एक्सपेरिमेंट करोगे, 2 ही पॉसिबल आउटकम होंगे. ईदर इट इज अ सक्सेस और इट इज अ फेलियर. तो अगर आपका एक्सपेरिमेंट ये चारों प्रॉपर्टी शो करता है, then you can study the probability using sample distribution. You can study sampling distribution using binomial distribution. So let us see whether this experiment is following these properties or not. So how many trials I am doing? 10 trials or 10 tosses. So this is fixed. Now probability of success is same. हर एक टॉस में 50% है सक्सेस का चांस. Each trial is independent. So first trial में या second trial में क्या आउटकम है, that is not going to affect next trials में क्या आएगा, right? And there are only two possible outcomes. So either you get heads or tails. Clear, guys? Any doubt? Anyone so far? Yes. Anyone has any doubt, any question so far? If something is not clear. Okay. So how, so you can solve this question, you can find out the probability using binomial distribution. So let me explain this binomial distribution using some easier example, then we'll come back to this particular question. So let us assume there are 3 kids in a family. Okay. You don't know their genders and you are asked, so there are 3 kids, that means 3 experiments, right? 3 experiments, 2 possible outcomes. So kid can either be male or female. So 3 experiments, 2 possible outcomes. Each trial is independent. So first kid is male or female, वो decide नहीं करता कि next kid का क्या gender होगा. So dependent हो गए तीनों experiments and probability of success is same. So हर birth में male होगा child के female होगा, that is 50% chance, right? So the question is, if in a family there are 3 kids, what are the chances that only 1 kid is a female, 2 are males and 1 is female? So हम लोग कैसे करते हैं? So there are 2 possibilities. First kid can be male or a female, right? If the first kid is male, second kid may be male, may be female, right? Similarly, if the first kid is female, then the second kid may be male, may be female. अच्छा, second kid male आया है, so again 2 possibilities, it can be male, third kid or female. अगर second kid female आया है, तो male, female. Similarly here, it can be male, female, और अगर second kid female है तो male and female. So if there are 3 kids, so you see there are 8 different possibilities. So what are those possibilities? Male, 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 female, male, female, male, and male, female, female. Then female, male, male, female, male, female, 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 male, and female, female, female. Right? So if you have 3 kids in a family, there are only 8 possible outcomes. So the total possibility is always 1. So if the total possibility is 1 and there are 8 possible outcomes, so 1 by 8 is possibility of each combination, right? So 1 by 8 would be 0.125. 12.5% possibility for any particular outcome. Now the question is, what are the chances that in a family there are only what are the chances that there is only 1 female in the family? So 1 female किस combination में possible है? You see in this combination we have 1 female, this combination has 1 female, or this combination has 1 female, और बाकी सब में either you have no female or you have 2 or more than 2 females. right? So there are only three possible outcomes. So plus 1.1.25, 0.1.25, 0.125. ठीक है? So if you add all these three, so then it will be 0.375. So that is the probability that out of 3 kids, 1 kid is a female, or there is 37.5% chance. और अगर आपसे पूछा जाए कि भाई तीनों ही मेल होंगे उसका क्या चांस है, देन इट इज 12.5 बिकॉज देयर इज ओनली वन सच कॉम्बिनेशन. तीनों फीमेल होंगी उसका भी चांस इज 12.5. और अगर आपसे ये पूछ ले भाई क्या चांसेस है कि तीनों जो किड्स हैं दे आर ऑफ सेम जेंडर, देन इट विल बी 25% बिकॉज ये भी सेम जेंडर है, ये भी सेम जेंडर. I guess we are facing a lot of problem with the network today. So I'll do one thing. I'll not continue with this example anymore. Okay. I'll again repeat everything in the next class. So we'll take up this binomial distribution again. Okay. So my suggestion is you read about it. Okay. And if you face any difficulty, bring it in the next class. All right, guys.
Yes, sir.
Okay then. So I'm stopping the class because we are facing a lot of network issue today. ठीक है then. Okay. Bye bye. Have a nice weekend all of you.
Thank you, sir.